Afternoon, everybody, and welcome along to today's session of the M Word on this sunny Thursday. Hope you're all having a nice day wherever you are. My name is Chris Martin, and I'm an applications engineer here at Man Machine. If you were expecting Rob today, apologies, you've got me instead. But
I am here.
Rob is here. I'm just going to start off by sharing my screen. So in today's session, we're going to be looking at the true benefits of Revit and 3D design. So we've got quite a lot to get through, and this will be the agenda for today. So we'll start off by looking at parametric modeling, so how working in a 3D environment within Revit differs from your 2D workflows that you may be experiencing in AutoCAD. And then some of the ways that we can automate our documentation from our model. So using schedules, using creating sectional views, that sort of thing. We'll then go on to our visualization and rendering using Twinmotion. So Twinmotion is inbuilt Revit tool. Well, it's a plugin for the latest versions of Revit where you can live visualize your model directly in Twinmotion as you're working on it in Revit. We'll also have a look at the energy analysis tool within Revit. So this is a way that you can you can do energy studies of your Revit model and provides those sort of functionality. Coordination and clash detection. Within Revit, there are inbuilt clash detection tools. So we'll have a look at those with an MEP file. And then we'll touch on how you can collaborate in the cloud using BIM Collaborate Pro and the Autodesk Construction Cloud. So let's go on to the first part of our session today, which is parametric modeling. So moving from a 2D environment to a 3D environment is one that can seem daunting to you at first. And for many of you out there, you may not be convinced that there's enough benefit to warrant the time needed to transition from that traditional workflow into something more collaborative. So in this webinar, we hope to demonstrate to you some of those key benefits of using Revit and a 3D design workflow by demonstrating the features that you have available to you when using the software. So working within Revit essentially uses working within Revit in the architectural space in essence uses a similar general workflow to AutoCAD. In AutoCAD, you've got your blocks or your dynamic blocks or line work to model these or other similar elements. Within Revit, we use what are known as families. So these families define all elements that are added to a Revit model. So that's whether we draw them in the case of your walls, floors, and ceilings, for example, or just place them if they've already been created in the family editor. Your standard architectural elements, so your tables, your chairs, for example. Where Revit starts to differ from a 2D software such as AutoCAD is that once we've placed these elements in the model, we can work with these families parametrically, meaning that the families contain properties which allow these elements to be variable, add information to generate outputs such as schedules, and help drive their relationship with other elements. So once you've loaded up a project workspace, you're met with this screen, which has various panels which contain different options, and I'll go over a few of these. So at the top, we've got our ribbon. So this is where we'll do most of our option selecting within Revit. So if we select one of the tabs, we're given the relevant options to choose from depending on what discipline we're working with. You've also got other tabs here to modify and manage your model. But typically the first few tabs are your elements that you'll be placing in the model, depending on what discipline you're working in. Then from here, if I say select wall in the architecture tab, I'm given options in the options bar to customize the height and the position of the wall I'm placing. So we can tell that we're in the command to place the wall because we have the modify place wall tab. And the ribbon changes to a green color, so it tells us that we're modifying something. Down in the bottom left corner, we've got a status bar, which is similar to your command line in Revit in that it gives you a prompt as to what to do. So in this case, it's telling me to enter my start point. We don't have a command line like you do in AutoCAD, but you do have the ability to use keyboard shortcuts to speed up the process. You can use the preset ones, or you can create your own as well. On the left-hand side, we've got our properties panel. So this shows us all of the information related to whatever instance of an element we have selected. So this combined with the options bar allows you to define different settings for, in this case, my wall, before, during, or after the process of actually sketching it. So you have that flexibility there to modify as you go. On the bottom left, we've got our project browser. So this is where we can access all of the different views, schedules, sheets, etc. that are contained within our project. So with Revit, which uses a typical BIM workflow, the model is central to the design process. So all of these different floor plans, ceiling plans, 3D views, elevations, they're all just a window into our model. They're all just showing, they're just different representations of our main model. And then the majority of our screen is made up of our working area. So this is where we do all of our design work. So currently I'm on my level 0 floor plan. You can see that's the active tab, and it's highlighted on my project browser. So for those of you who are looking to move from 2D to 3D, you'll be pleased to know that the majority of your design work is still done in a 2D space, such as a floor plan or elevation. But then from that, we can visualize what we've designed in 3D. So by default, when you start a new project, you will have a level 0, a ground level, and one upper level created for you, and also a site plan. But you can create as many other levels as you like. So for the purposes of this, I'm just going to create one more level. So I'm going to open up one of my elevations from the project browser. I'm going to come up to my ribbon and select level to create a new level. So within Revit, your levels are essentially points on the model whereby you can constrain other elements to them. So it doesn't necessarily have to be a floor. It could just be a height that you want other elements to reference to. So for example, you might have a parapet level for above your roof level if you need to reference elements to that. So you'll see shortly when I start creating elements that setting up these levels and constraining elements to them is quite important in terms of the design process within Revit. So I'm just going to create a level above my level 1. So we've got within Revit, you have similar sort of tracking tools that you do to within AutoCAD, so I can make sure my level is nicely aligned with the others. I've also got my witness line dimensions on the left-hand side, which can help me to position that, but of course, naturally, I can reposition it afterwards if I'd like to. I'm just going to draw another level above my level 1 at 6,000 mil, so 6 meters, and I'm just going to rename it to be called roof. I'm also going to need a floor plan for this level. So currently I've just created a level without any floor plans. So I'm just going to come up to my ribbon view tab, plan views, and create a floor plan for my roof. You'll see as soon as I do that, it gets added to the project browser, so I can use that level to draw elements on in plan. I'm just going to go back to my level 0 view. And for this example, I'm just going to draw a basic wall outline. So from the ribbon, I'm going to go back to the architecture tab and select wall. And you'll see the information in the properties window, as when I did before, it changes from information relating to the floor plan itself to information on the elements that I am drawing. So we've got information in the properties window, such as how it's going to be constrained. So like I mentioned a minute ago, we've got our base constraint and our top constraint. We can choose from those levels that we've created, and dimensions, etc., other information. Either you'll find it in the properties window or in the options bar. But quite often it's duplicated between the two. So it just becomes a case of how you become most comfortable with working within Revit. And I'm sure that's something that you'll naturally work out as you start to use the software more. So I'm just going to choose in the type selector a wall which has an outer render. And on my working area, I just need to click to start drawing a wall, and then move my mouse in the direction that I want the wall to go. And then I can just type, either use the witness line dimensions or type an actual value into my keyboard. So I'm going to go up 10 meters. I'm going to come across 15 meters. And then join it back up in a rectangle. So again, you've got your snapping and tracking tools like you have in AutoCAD. So using the same sort of familiar symbols. So it's all should be quite familiar to you, those sorts of tools. And I'm just joining it up in a rectangle. I'm just going to make my wall go up to my roof level as well as the top constraint. So whereas in AutoCAD, I'd be drawing line work from doing this sort of process, in Revit, I'm drawing physical components from the outline. So you can see, if I zoom in, I've got a wall that's made up of multiple layers which represent my my render, my block work, my air layers, another layer of block work, and my plasterboard. And at the corners, it's all nicely sort of joined up for me. If I wanted to now modify any part of my wall's properties, including the actual type of the wall, then I can just come into my working area and just select one of the walls, and then again in the properties window it will come up with that wall type. So I'm just going to open up a 3D view to represent this a bit better. So I open up my 3D view from the project browser. Make sure that I can see everything in my view. And then I'm just going to tile my windows. So we have the option in view, tile views to tile my windows, or that was a keyboard shortcut, WT. So now say if I select one of my walls in my floor plan, you'll notice that it highlights in my 3D view as well. So this is what I mentioned a short while ago, is that when you are working within a Revit model, you are, each view is one portal into the central model. So it's basically just a different representation of exactly the same element, just from a different perspective. So now if I went and changed this wall, for example, to one that's got brickwork on the outside, you'll see that that change automatically takes place in my 3D view. I'm just going to undo that. So I've got render on all of my outside walls. So now I'm going to go ahead and select a floor. I'm just going to untile my views for now and go ahead back to my architecture tab and create a floor. So with floors, I can use the existing wall boundary to create a floor. So I have boundary line selected and I just need to hover over one of my walls and press tab. As these walls were all created in one command and as I have them all joined up, that intelligence within Revit recognizes that those walls are joined and that I'm going to want to use them to draw other elements around them. So once I've highlighted it, I can just click to create my floor. And as this is my ground floor, I want it to extend into the core. So you can see the pink sketch line represents where that floor is going to be drawn to underneath my wall. I'm just going to press the tick to create that floor. And you can see in 3D that that's been created as well. And then to create my ceiling, I need to go to one of my ceiling plans. So I'm going to go to my level 0 ceiling plan. And ceilings work in a similar way to floors in that I just need to select a boundary. So select ceiling from the ribbon, and if I have automatic ceiling selected, I can just choose a wall boundary to draw my ceiling. If I have ceilings that I'd want on multiple different levels, say I had a drop ceiling at one point, I would want to maybe sketch a ceiling so that I could represent those ceilings at different heights. But for this, I'm just going to use automatic ceiling, click in the empty space, and that ceiling has been created for me. And now I'm going to do a similar process in level 1. So again, I'm going to create my floor. With this one, I need to ensure that when I click, that I'm clicking just inside my wall with it still highlighted. As this is an upper floor, I don't want it to extend into the wall core. I just want it to cut through my plasterboard. So as it has done, it recognizes that as it's Revit recognizes that even though I've got to core selected as it's an upper floor, I want to just extend it into the plasterboard only. And now I can finish that one. Actually, I just need to make sure it's a timber floor as well. I can select finish for that one. And now I want to tell Revit that yes, I want to join the geometry of the floor to the wall and cut out any overlapping volume of the wall out of the walls. So you'll see why this is important in a minute. So if I quickly create a section through my wall, with Revit, you don't need to worry about having to project lines from your floor plan to manually draw your section views. Like in AutoCAD, you can simply create section views by drawing a section line through your model, and then you have a fully generated independent view of whatever you're sectioning. Just going to make sure my detail level is fine so I can see my layers. And you can see that I've now got the plasterboard of my wall connected to the structure of my floor. The floor finish, which is my chipboard, has been cut out to allow this join. And also the rest of that plasterboard has been cut out to allow my floor core to join into my wall core. So again, this is something that you would probably spend a little bit of time doing just on this one instance for in AutoCAD. So you'd have to trim out all of the line work to get an accurate representation. Within Revit, it recognizes which elements need to be connected to each other. So it does that change, it carries out that change automatically for you. On the bottom level, if I had created a foundation as I would have in real life, then the same relationship would be true with my ground floor. But for the purposes of this, I'm just going to do it on my upper floor. So let's go to the roof level and create a roof. So I just need to ensure that I'm seeing my walls, so I can set my view range to see slightly down from my roof level so I can see the top of the walls, place my roof on. And then I'm going to go to my architecture tab, select roof. I'm just going to leave it on the default one for the purposes of this. And I'll leave the overhang as 250. And then I just need to click around the edge of my walls. Because I've got defined slope on, it's creating a pitch of 30 degrees for each of my slopes, which is fine for the purposes of this. But if you wanted a flat roof, you can choose to turn that off or set a probably like a 5-degree pitch or something like that for a typical flat roof. And I'm going to finish that. So you can see if I go back to my 3D, I've got something coming together which looks like sort of like a house with no access points currently. So what I can do is I can start adding some doors. I'm going to go to my level 0 floor plan and come up to door on the ribbon. And with doors and windows and some other elements, depending on how they've been set up, these are what's known as wall-hosted elements. So you cannot just place them in an empty space. They have to be attached to a wall as they would be in real life. So I can again use those witness dimensions to help with my positioning, but typically you'd want to just place elements down and then move them unless I knew, for example, that I wanted to place this door exactly centrally. You'll see that Revit will snap centrally to the internals of that of those walls. So I can place my door, which is as I'm going to do it now. But typically you'd probably just place the door down and then use your modify tools, which should be familiar to you if you've worked with AutoCAD. Some of these symbols, you typically just place it down and then use your modify tools to reposition it. So I'm just going to place it on my wall. And you can see an example now of another example now of that parametric intelligence when you're working within Revit. So Revit recognizes that for a door placed on a wall, that some geometry has to be cut out, and all of the so we've got the geometry cut out for our opening, and then all of the framing has been fixed appropriately around that wall. So you can see if I zoom in as well, that the ends of the wall have also been wrapped to allow for the door to be placed. The ends of the door plasterboard, sorry, have been wrapped to allow for that door to be placed on the wall. Now that that door has been hosted on a wall, I can quite easily move it. I can just drag it, or I can use the modify commands. And Revit recognizes that that door has to remain hosted to the wall. Without overlapping or clashing geometry. So wherever I position it on the wall, it will cut out that geometry from the wall. It's worth noting for this example today that I'm using some preloaded families. So I've got a few different types of doors in here that I wouldn't necessarily have if I was opening up one of my standard templates. But you can quite easily load in families from the Autodesk library, which has a decent amount of families to get you going. All of the families I'm using today are from this library if they're not already included in the project by default. So now I'm going to go ahead and add some partition walls. So again, coming to my architecture tab and selecting wall. And I could use that tracking if I wanted to. I'm going to just create a reference plane at my center point and use the offset tool to place a couple of partition walls either side of my door. I just need to select partition wall from the from my type selector. Choose one of the different types. I'm going to define an offset in the options bar. I'm going to say 900 from to the left and 1400 to the right. So I can use the pick lines tool. Now that I have my reference plane, I can exactly position those walls as I want them to be positioned. So 900 to the right, to the left, sorry, and we'll go with 1400 to the right. I'm just going to create a few more walls just by drawing them. So using the line tool in the draw panel. I've still got my offset on. Let's set that back to 0. Okay. So you can also constrain components so that they remain in position if you need them to be, if you have a vital dimension between two components that needs to be maintained, you can use dimensions to do that. So say for this front external door, I want my door to always be 397.5 in this case from the partition wall. I can make this dimension, if I wanted to, I could edit this dimension to move that door along the wall. If I'm happy with that dimension, I can click on the little symbol to make it permanent. And then I just need to lock that dimension using the padlock. So now if I say change the type of this door to one that has a side panel as well in my type selector, then that dimension from the partition wall to my door will be maintained because I've set that up as a constraint by creating that dimension and locking it. So any dimensions that you create will be visible on this view permanently, essentially. So until you delete them or turn them off. So if I added this view to a sheet, to my documentation, then that dimension is on that sheet. If I wanted to just keep that constraint but not show the dimension, I could right click, hide in view elements, and that dimension is just sitting in the background. So that constraint is still there, but it's just not showing the dimension on our view here. Okay, so I'm just going to add a few more different types of doors to access my other rooms. And there we go. Okay. So that was just from the type selector, just selecting different types that I have available to me. So each of these doors in single is its own family, and then we have different types contained within that family that we can select to place in our model. And I also will need some windows. So like I say, windows like doors are wall hosted elements. So you can only place them on a wall. I'm just going to go around quickly and place a few. I'm going to leave out my back of my house because on the back of the house, I want to create some nice patio doors. So say this is our lounge and our kitchen. I'll add some nice sort of full length patio doors from those two rooms. So to do that, I can use curtain walls. So if I come up to my wall again on the ribbon and scroll right down to the bottom, I've got curtain wall options. I'm going to use this exterior glazing option, which will give me glazed panels included within the curtain wall. I need to make sure that I've got automatically embed checked on the type properties type selected so that the curtain walls cut the wall and then just position them along my back wall. And you'll see, like with the doors and the windows, they cut out the geometry from the wall. So instead of just placing them like we did with the doors and the windows, we're just sketching that cut into the wall essentially for our curtain walls. I'm also just going to select them both and add a slight offset from the floor. And if I go back to my 3D, I could have my 3D open alongside at the same time working on this, as I had earlier when I was tiling my views. And with curtain walls, so curtain walls are made up of multiple components, multiple individual components, which make up the curtain wall in its entirety. So I can individually select, say, a couple of the panels, a couple of the glazing panels, and change them to something else. So I could change them to not be glass, to be a solid panel, or I could change them to a door. So this is a door that I've just got preloaded into this family, into this model, sorry. And you can see that that automatically sizes that door according to the size of our panel. I could then go to my ribbon and choose mullions to add some structure to my curtain wall. So I just need to do that, to just select the boundaries of my curtain wall panels to place that those structural elements. So we've created a few elements on our ground level, but we don't have anything on our upper level so far. And if you had an upper level which is similar or the same layout to your level 1 layout, you don't need to spend time just modeling the same layout. You can simply come in here and select all of those elements. So Revit works in the same way with selecting elements with a crossing window as AutoCAD, in that I can just use a crossing window from left to right. As long as I've touched the whole of the element, it will be selected. If I select from right to left, I just need to touch a tiny bit of the element for it to select. So exactly the same as it works in AutoCAD. So I'm just going to make sure that I'm not copying my walls. And I also don't want to copy my floors or anything to do with my curtain wall. I just want to copy my doors and windows and actually my partition walls as well. So I'm just going to select them manually. And then I can you can copy them to clipboard just using Control-C. I think I was trying to copy that section line as well. And then go to Paste, Align to Selected Levels, select Level 1. And if I go to my Level 1 plan, you'll see that that exact same layout has been copied in the same position, just on the level above. If I go back to my 3D, we've got quite a nice sort of looking design. We could maybe have added some windows on the back above our curtain walls, but that can be quite easily done. And you'll see if I just use my section box to cut through the 3D, I can see what the layout looks like in 3D. So I've got my two levels, but I don't have any way of traversing between the two. So I just need some stairs, which I'm going to place on level 0. So with stairs, Revit will take a start and an end point, and then based on the dimensions set in your properties, will calculate the number of rises that you need to traverse between those heights. I'm just going to use the default that it's set for a distance, for a height distance of 3000, which is 18 rises. And I just need to draw my run of stairs. I'm drawing on the right hand side of the stairs. Just need to draw those stairs in my hallway. You'll see as I draw it, it will give me live information as to how many more stairs I need to complete that run. Once I've drawn it, I just need to click to finish and click the green tick. And you'll see you've got those that staircase created. So if you use a type of staircase that has railings included, it will create those, but then once it's created, they're separate elements, so you can control them and delete them if necessary. So I'm just going to delete the ones on the wall. And then the last thing we need to do, so creating stairs doesn't create a cutout or a shaft between the two floors. So we need to create that shaft which just cuts through the geometry of the floor, any roofs or ceilings. So on Architecture tab, I'm just selecting shaft, go back to my level 0. And for the purposes of this, I'm just going to create a shaft which is just the same size as my staircase. And if I go back to my 3D, you can see that we now have that opening. Of course, I'd want to add some banisters around my upper floor, but it's quite a quick way of cutting through geometry using that shaft tool. We can quite quickly and easily modify components to be a different type. So as we did with the front door, simply by selecting an element and changing it in the type selector. So I'm just going to change the front of my house so that I've got a couple of bay windows. I'm going to remove a couple of the outside ones just by pressing delete. And then selecting these two remaining front ones. Coming over to my type selector, which gives me information on the current families that are selected, and changing them to one of my bay window types. So Revit will maintain the origin of the component when it's positioning the new type. Or if you've created that dimension constraint like we did with the front door, it will respect that, that dimension. So as you can see, you can quite quickly, within the space of 40 minutes just that we've been doing this, you can quite quickly put something together from primarily working in 2D as you would in AutoCAD, but now from mainly working in 2D, you have this 3D representation, which you can then use to pull other information from. And we're going to have a look at this next. So one of the ways that we can utilize this information now that we have this model to save tons of time is during the creation of our documentation. So with Revit, gone are the days where you've got to manually count objects in your model and fill in a table. As we've seen when you're looking at parametric modeling, making a change to one element modifies other associated elements that are connected to it. So like with our door that was hosted in the wall, and that also updates the parameters in the properties window. So this information is carried through to the schedule automatically. So schedules maintain that live link with the family that they're associated with. So by extracting information directly from the model and placing it in the table. So you don't have to worry about making a change in your model and then did I update the schedule to show that information? Revit automatically is reading whatever is in the model and updating the corresponding information in the schedule for you. So we're going to have a quick look at creating a door schedule. So I'm just going to come over here to my project browser and create a new schedule. I'm going to say doors. So as I added different types of doors, this will give a good representation of the kind of information that we can see. And press OK. And then once we've started the creation of that schedule, we have 70 different fields that we can choose from, which are all just properties, either from our properties window. So these are instance parameters, and properties from our type properties window. So type parameters. So instance parameters are just relating to this one instance of the window. Type parameters are relating to all instances of that one type. So I'm just going to choose a few different properties to schedule. So let's go ahead and choose a few. So I'm going to say family, my level, height, width, finish. Let's go, yeah, finish and frame material, and that'll do. So just by selecting those parameters, Revit populates the schedule with each of those doors contained within my model and the information contained within those parameters. So I've got a bit of information here on which level they're on and the height and the width. If I add information to any of those parameters on those elements within my model, it will automatically update on the schedule. So say for my, let's just select one of my internal doors. I'm just going to change the frame material, the timber, and the finish to primed. And if I go back to my door schedule, you'll see that information is automatically shown on that schedule. Likewise, if I add information in the schedule, it will populate those fields on the properties window when we're in the model view. So I'm going to select my external door, my front door, and I'm just going to say it's a UPVC door. Now I don't have to go and find that element in the model. If you've got quite a large model, you can simply come up to the ribbon and select highlight in model, and it will very quickly take you back to your model view and highlight that element for you in its position. So that's quite useful to know what element you're scheduling, what element, where that actually sits in the model. And you can see on my properties window that frame material parameter has been updated to include that information. We can also filter. Information on from our schedule. So I'm currently showing all of the doors, but I may want to just say filter my level 0 doors. So I'm only seeing my level 0 doors in the schedule. I can sort and group them, the different information as I wish. I can add other fields that I want to schedule after I've created the schedule. So once you've created it and selected your fields, that's not a be all and end all. You can come in here and edit it at any time. So all of this adds up to sort of a vastly more efficient building design process and helps to eliminate mistakes that would naturally crop up from this sort of manual task where you're making a change in your model and having to update corresponding information. It's all updated for you. So now that I've got a model, I can use this model to create some documentation from. So what I'm going to do first is I'm just going to create a couple. I'll probably use this schedule that I've got, this section, sorry, that I've got already. I'll use this section, just extend it a bit by selecting it and using the grips. And then I'll create another section on one side. So I'll use these views to add to my documentation with my floor plan. Note that currently on the section bubbles, we've just got dashes in the circles. So you'll see why that's relevant in a minute. So to create a sheet, I'm just going to right click and select new sheet, choosing my title block. And then your sheets they're essentially just your paper space, equivalent of your paper space in AutoCAD. So yeah, where you produce your construction documentation. So now that I've created my sheet and I've got my views that I want to add to the sheet, it's the process is just as simple as dragging and dropping them from the project browser into the sheet to place them on the sheet. So I'm just going to add I've added my level 0 plan, and I'm just going to come to sections and add those two sections. I could also add that schedule if I wanted to. And then, so with the scaling of these views, it's all controlled just from the view scale here. So there's no more messing around with scaling your viewports, locking and unlocking them. You can just select a scale from the list, and it will automatically scale all of the elements contained within the view for you. So I've added that floor plan and those sections to my sheet, and you can see now that in my floor plan, those two sectional bubbles, those section lines, have populated with some information. So it's telling us that those sections are on sheet A101 and they're detail number 2 and 3, which corresponds with the two sections I have added. So again, there's that intelligence there between and the relationship between the different views. It's recognizing when those views have been placed on sheets, so you don't have to come in and populate those bubbles yourself. Okay, so the next thing we're going to be looking at is visualization and rendering. I'm just going to go to my next file for this. So some of you might not know what a render is. So a render is a photorealistic image of your building model. So within Revit, we have a few different options for rendering directly from the native software. So if we go to our View tab, so this is a model I created earlier, which has a bit more detail on it than the one that we've been working on so far. It will give quite a good representation of what a render will look like when we open up one of the rendering tools. So on the View tab, we've got a few different options for our render. So we've got render, cloud rendering, and twin motion. So I'll go through those different options. So a render is Revit's in product version. So using this option, you have control over the settings and the rendering environment. You can also use this as quite a quick way to get some immediate feedback on your materials, etc., that you've used, so how they'll look once it's rendered. Also, you don't have to have an internet connection with this option. So you can choose to quickly save renders as a view in your project. However, when you're working on this option, you can't continue, when you're using this render option, you can't continue working on your model. But below, I've just got a couple of options that have been saved into a couple of views, sorry, that have been saved into my project of how those outputs look. I probably could have done with having a bit more lighting in the lounge, but this is sort of shows us that you can use different lighting environments for your renders. The second option is cloud rendering. So this allows you to work in your model at the same time as a render is running in the background. So it utilizes the Autodesk rendering service. So you don't need to have expensive local hardware to carry it out. All of those renders are done in the cloud and stored in the cloud in the render gallery. I'm not going to go too much into these options today, but note that with this, with the cloud rendering, you can create solar studies, illuminance simulations between your natural and your artificial lighting, and much more. The third option is twin motion. So twin motion is the free add-in in Revit from version 2023.1 onwards. So once you've downloaded it, you can open twin motion directly within Revit. So let's just open twin motion, which I've got open already in the background. So the benefits of using twin motion over one of the other two options that I've just explained is that it provides you with real-time rendering of the current model. So you just need to ensure that when you're rendering, that you have the auto sync option selected in your Revit browser. So under twin motion, just making sure you've got auto sync selected, and then whenever you make a change in the Revit model, so let's I think I might have changed my zoom settings to be a bit slow. Whoop, that's too fast. That's better. So whenever you make a change to the model in Revit, it automatically renders that in twin motion for you. So say this sofa that I've got, this outdoor sofa, if I reposition that just as a quick example, you'll see that that change has automatically occurred in the Twinmotion render. We can also add additional assets from the Twinmotion library into the model and populate the surrounding landscapes and textures. So say if I selected one of my trees, you get quite a sort of nice photorealistic version of these types of elements in if you're using the assets directly from Twinmotion. There's loads of different objects available here by default. So say I might want to load some furniture, just need to select it from the list and position it on in your model. You can also replace objects from the Revit model with assets from the Twinmotion library. So it just replaces it in the Twinmotion render. But if you have a family which maybe looks a bit sort of like blocky or not that realistic in your model, you could use Twinmotion to replace it. So I'm just going to have a go at doing that with this bed that I've got. Just by selecting it, right-clicking, replace object, coming over to my library and selecting one of the beds I have available and just dragging it into that replace object box on the right hand side and replacing it in my view. So already I've got this more sort of photorealistic version of my bed compared to what was shown on the Revit family. You can also reassign materials for existing geometry with materials from the Twinmotion library. So say in my bathroom, I might want to add some tiling on the floor if I didn't already have that tiling available to me. I just need to select the material and drag it into the view onto the surface that I want it to be shown. And you've got that nice sort of render shown on that material. So from there, I could create some images which I can export out. So I've already got a few included in here by default. You can set the time of day. So I've got a few that are set sort of like at in the evening here. So you just need to sort of navigate around the model. Say if I wanted one from the back, navigate around the model and just click on the plus to create a new still image. But you can also create videos and panoramas using the Twinmotion tool as well. So that's rendering. Another benefit of using Revit is that you have the ability to carry out energy analysis. So reducing buildings' impact on the environment is something of a hot topic at the moment in construction. So this is due to the increased awareness of how right from the early stages of the design process, decisions made with your materials and the like can have quite a large impact on your environmental footprint of your building. So not just how it's operated post-completion, how it's actually designed as well. So Revit offers you energy analysis tools that allow you to evaluate the energy performance of your designs so you can make informed decisions and improve your energy efficiency. And this helps to design sustainable and environmentally friendly buildings. So I can do that using the Analyze tab. So I'm going to stick with this model that I was doing my render on. And I just need to first set up a project location. So that was from location on the ribbon. And I'm going to go with tame, where we are in Manor Machine. And I just need to select the nearest weather station to give me climate information for my location. And then once I've gone through the process of setting up these various other options, we're not going to go through the whole process today, as it involves some sort of quite detailed settings. But if this is something of interest to you, then do get in contact with us. Once you've set up all of these settings, I can then go create energy model. And I can show you what that looks like. So for a building of this size, it typically takes a few minutes. Obviously, if you had a larger building, it might take a little bit longer, but it typically doesn't take too long to come up with this information. So this is in the Autodesk Insight dashboard. I've got some various different dashboard cards available to me that we can use the information to optimize our building. So we can see from the energy analysis that our energy consumption will be estimated at 319 kilowatt hours per meter squared per year. So we have a bit of work to do there. That's quite high for a new build. And then each of these dashboard cards will look at different building elements to try and optimize your energy efficiency. So if I select one of my wall to window ratios, let's go with I thought I had one on my southern walls, but maybe not. So this tells us that currently my on my northern walls, I'm made up of 52% glazing, but that an optimal range would be something less, as I'm reducing the amount of glazing would reduce the amount of heat loss and also contribute to heating efficiency. So and it gives you sort of quite accurate figures as to what percentage of glazing relates to each of those figures. We've got other options here that may be of use to you. So wall construction. This tells me that if I have the budget to use steel insulated panels, SIPs, for my project, then I can improve my energy efficiency by an estimated 15 kilowatt hours per meter squared per year. So just by making that change, I would make my building quite a lot more efficient. So yeah, there's quite a lot of information in here of varying usefulness, but it's quite a useful tool that can be quickly generated from an energy analysis. So the next part of this is looking at coordination and clash detection. So I've got an MEP file here, which I'm going to use for this process. So with Revit, you can utilize the interference check tool to generate a list of your geometry clashes between multiple model categories. So whether they're all contained within your central project model or between your model and a linked project model. So this way you can highlight conflicts between the different disciplines that are working on a model. So that's whether you're an architect, a structural engineer, an MEP engineer, you can ensure that the elements that you're placing are clear of other building elements. And then by spotting these clashes at the design stage, an early stage, this will ultimately prevent construction delays and costly rework later down the line if these conflicts are ultimately made it to site. Hopefully, if you use these tools, then they wouldn't. So in this example, I'm an MEP engineer and I have my model open, which has architect and structural engineer files linked in. So for the purposes of this demo, I'm just going to clash detect my MEP model against the structural model. So I just need to make sure that I have turned off my architectural file. And then by going to the Collaborate tab, under Interference Check, I can choose Run Interference Check. And from here, I can select from all of my different model categories. So each family falls into a model category. So I can select from all of my different model categories to clash against each other. So I'm going to clash detect my ducts and my duct fittings against the structural model, which contains floors and structural columns. And I'm going to press OK. Yep, I'm going to press OK. And then this will give me a list of any interferences between geometry for those elements that I've selected. If I scroll all the way down, I've got a clash with my structural columns at the bottom. And then if I select the plus to open it, I can see those elements highlighted. So I've currently got two structural columns that are clashing with my ductwork here on the on my first floor, or just above my first floor. So what I need to do is I just need to go into my level 2 plan. So yeah, I think level 1 is the ground floor on this model. And then you can see the clash at the top here, where I've got my structural columns and the ductwork. And then for the purposes of this, I'm just going to move it downwards. Obviously, I wouldn't necessarily want to just be dragging things without checking how they're connected. But I now know that that ductwork isn't clashing with my structural columns. So now if I go back to my interference check and do show last report, and if I choose refresh, I can see that that clash is no longer, that interference is no longer listed. So as you can see, you can clash detect multiple model categories together across both the central model and link files. I could also, if I wanted to, I could select to export this to create an interference report as an HTML file, which I can then copy into an Excel spreadsheet, for example. So a brief look at some of the clash detection within Revit. There are more involved clash detection tools available to you from Autodesk. So Navisworks is a bit more involved than Revit at doing clash detection. But for your general geometry clashes, Revit does a good enough job. And then the final thing we're going to be looking at is cloud collaboration. Let me just pull up my model. So cloud collaboration is a key feature within Revit to streamline your design processes with your team and unlock Revit model co-authoring. So with BIM Collaborate Pro, which is part of the Autodesk Construction Cloud, known as ACC, which is Autodesk's cloud-based common data environment, CDE, multiple users can both co-author and collaborate on the same Revit file in the cloud, synchronizing their file to view the latest changes in real time with other Revit users, which is known as work sharing. So I'm not going to go through the process today of how to set up cloud collaboration. We've got videos on our YouTube channel which go into that, and blogs on our website, which I'm sure will be linked to this video once it's posted on YouTube. But some of the key pointers of this workflow are that so traditionally you'd have one user who has the project file open, and then it's locked for editing for other users. When you save a model to the Autodesk Construction Cloud and set up work sharing, this allows multiple users to open and edit a project at the same time, and then synchronize their changes in real time back to the cloud. So you would use that, use the synchronize option on the quick access toolbar. And once you've synchronized, anyone else who's working on that file at the same time will be able to view your changes once they have synchronized as well. Work sharing also allows, and it's telling me that I need to synchronize because I've made some changes. Work sharing also allows users to check out building elements known as work sets from the model to work on. So we have we can see our work sets down the bottom on the ribbon. So yeah, you can check out building elements to work on while other users are working on the model. So you take ownership of a work set. So depending on the size of your project and which disciplines are collaborating on your project, you'll want work sets to either be split into your building elements. Say if you just have architects working on file, maybe you want it to be, you'd want work sets to be split into zones if you had quite a large building, or maybe into discipline elements. Say if you had architects, structural engineers, MEP engineers, all collaborating on the same project. The users either take ownership of a whole work set to work on. So you can see I've taken ownership of these 3 work sets, or borrow an element from a work set. So for this, you need permission from whoever is the current owner of the work set to be able to borrow from a work set to work on specific elements. And then once you have once you finish working on the element, then you relinquish those that work set so that others can work on it. So there's a few different options for collaborating directly within Revit. And then the other side of that is the BIM Collaborate offering on the Autodesk Construction Cloud platform. So with the design collaboration module, which is included as part of your BIM Collaborate Pro license, which you would need for Revit work sharing, teams can share their design data as packages of design files and any supporting documentation. So each of these symbols on my project timeline is a package that has been shared by that team with the other teams that are collaborating on that project. So each team has their own Revit file, and then at various points in the project timeline, packages have been shared, and then other teams can so I'm part of the MAM architects team at the moment. Other teams can then select a package and choose to consume them in their workspace if they haven't already consumed them already. So that just brings it into your cloud workspace so you can incorporate it as part of your design. So it's worth noting as well that you also have model coordination included with BIM Collaborate Pro. So this is another tool that you can use to clash detect on your model. With model coordination, the clash detection is occurring in the cloud, so you can just choose different views to clash detect against. And then your wider stakeholders then have a scope of those issues. So you can see here on this model, I've got a clash with the wall and the venting. And anyone who has access to the cloud platform would be able to see this clash and comment on it, add issues to it, that sort of thing. Again, if this is something that's of interest to you, then please do get in contact with us and we'll be able to talk you through BIM Collaborate Pro in more detail. Okay, so I hope this session has been useful to you. I know I've thrown a lot of information at you, but hopefully you can see from some of the benefits of working in a 3D some of the benefits of working in a 3D workflow with Revit, and all of the additional tools that you have available to you. If there's any parts of what I've spoken about that sound of interest to you, again, please do not hesitate to get in contact with us at Man & Machine. We'll do our best to steer you in the right direction, whether that's with training or maybe you just need some additional support. We'll do our best to help you. So thanks for watching this session today and have a great afternoon.